As a reminder, hurry to that NPR. We're handing out floats for a minimum dollar donation. All students, $1 for a root beer float.
Okay, sorry about that. Here's an example of a lab report. I have a title, I have a purpose, and let's see what I say. Given the horizontal velocity of a ball as it rolls off a table, calculate where it will land. Verify our calculation by testing it. Can we make a basket? Alright, so sort of a brief summary of what are we doing and why. Procedure, and this, sometimes you can do the procedure afterwards because you're kind of figuring out what to do initially, but it's just a set of steps. So, set up the ramp, roll ball down the ramp, use video physics app to calculate horizontal velocity of ball as it rolls off the table, etc., etc., etc. So again, procedure is a set of steps. The idea, so when you're thinking about your procedure, because you're doing the lab and I know how to do the lab, and you're writing this up and sort of wondering, well, what should I write? Think if a student were to come into this class and have no idea, and you were to give them your lab notebook, they should be able to read it and recreate the lab. So that's sort of the whole purpose of the procedure here, is someone else who is not in the class could repeat your experiment just as you did it simply by reading your lab report. Okay. So related to the procedure is the diagram, and you could even put the diagram first or maybe even involve it in the procedure, but you should definitely have a diagram. Notice how I have labeled these things. Okay, so when we're talking about height of the desk, this is what we're talking about. When we talk about calculated horizontal distance the ball will travel, this is what we're talking about. Books, tennis ball, etc. So draw something, label the pieces, and make sure that this is totally related to the procedure that you just wrote. When you go to take your data, the most common mistake is students don't have units involved in their data. So like in a table, if you put the seconds here and the meters per second here, that's fine. You don't have to write them on each individual number because you're indicating what those numbers represent. Use words to describe what the numbers are. That's wonderful. Okay. Here, I say this is the average of the last 5 values. So from the video physics app, we had values for velocity as it rolled off the table, and they were different. They were not all exactly the same. So what we did, what most of we did, is averaged some of them or all of them. And here I say we averaged these because it looked like the ball was slowing down slightly. That could actually be part of the analysis, but I thought it appropriate to list it here just because here are the numbers and I'm reporting this value. So if somebody were looking at your data table and then looking at this, they'd be like, that's weird, how'd they get that? And so having this description right there on that page is helpful. Turns out the mass of the ball wasn't important at all, but sometimes that's the case. We measure stuff, we record it, including units and whatnot. Okay, data. Oh yeah, another thing I'd like to bring up is I did this in pen. Notice how I'm crossing things out. That's okay. Okay, this is not the neatest lab report in the world. It does not have to be neat. It has to be correct, and it has to have detailed information. So let's take a look at the next page. Okay, calculation and analysis. So I made a rough sketch. This is not the entire diagram that we had in the diagram of apparatus, but I do have an arrow indicating the horizontal velocity, and I do have the height of the table listed because those are the values we're actually using here. So perhaps most importantly for many of us is, instead of just having some equations scribbled down and some numbers with some answers, I have my calculation shown. I'm showing the equation that I'm using, I'm showing substituting in, and then I'm showing my answer. But this part right here, I have a sentence that's actually describing what this is. we use the height of the table to calculate the time it will take the ball to fall. And then we use the horizontal velocity and the time in the air, okay, to calculate how far, and I'm specific horizontally because this distance is very different from this distance. It will go before landing on the ground. And again, I listed the equation, I substituted in, and then I'm calculating a value. And then check this out. I have this calculated, and then I write another sentence describing what that actually is. So if we place the cup about 26 centimeters in front of the edge of the table, the ball should land in the cup. So I have calculated what I'm trying to calculate, and then I have a sentence that describes what that actually is. What does it mean in terms of the lab? Lastly, conclusion. So for conclusion, it's sort of a summary, but you're supposed to state a claim. So you claim something, and you have evidence to back it up, and you sort of reason your way through. Why does this evidence show this? So here's what I say. We calculate that a ball rolling down a ramp from a height of this will leave the table with a horizontal velocity of that many meters per second from data in Video Physics app. Okay, and then using that and the height of the table, we calculate the ball will travel horizontal distance. So this is sort of the thesis. We calculated the ball would travel a horizontal distance of this many meters. I could have started with that, and it may actually have been better before hitting the ground. Then we performed the experiment again, and the ball did land in the cup, confirming our calculations. So this is our claim that the ball will travel this far horizontally. Some evidence backing that up is that it actually did when we reperformed the experiment, but we also have data and calculations confirming why this is the case. So that's a brief summary of what a good lab report would look like. Thanks.